Hello everyone. Today we're looking at three more congruent triangle theorems. The first one of which, if we have two angles and an included side of one triangle that are congruent to the corresponding parts of another triangle, the triangles are congruent. This is known as the angle-side-angle theorem. That included side is going to be between the angles being used. It is the side where the rays of the angles would overlap. So it would look, if we had a triangle set up, it would look like angle, another angle, and the side between them. We also have a situation where if we have two angles and a non-included side of one triangle that are congruent to the corresponding parts of another triangle, the triangles are then congruent. This is known as the angle side. It would look like such that we have an angle, another angle, and a congruent side. The non-included side can be either of the two sides that are not between the angles being used. So you could also think about this in terms of the, alternatively, as the SAA if we had the setup of, let me fix that triangle for y'all. Side, angle, angle, bit. This last one applies only to right triangles. So, only right triangles. If the hypotenuse and the leg of one right triangle are congruent to the corresponding parts of another right triangle, the right triangles are congruent. We call this one the hypotenuse leg theorem. Now note folks, this is only for right triangles. Partially because in right triangles, we already have a known angle. So this is going to be kind of like our side, angle, side congruency from previously, but only for right triangles. Such that if we have a right triangle and the hypotenuse as well as the leg are congruent, then the triangles will be congruent. All right, let's take a look at some practice and walkthroughs. So, side, angle, side postulate. So if angle, let's get better colors. If angle A is congruent to angle X, and if side AB is congruent to side XY, and angle B is congruent to angle Y, then triangle ABC is congruent to triangle XYZ. For our angle side postulate, all right, some small typos here. I'll fix them on the notes in the folder. If angle B is congruent to angle Z, and if angle A is congruent to angle Y, and side AC is congruent to side XY, then triangle ABC is congruent to triangle YZX. Remembering, folks, the order of these letters matters as they correspond to the corresponding angles. All right. Hypotenuse leg postulate. So if angle A and angle X are right angles, that is to say they equal 90 degrees, and the hypotenuse CB is congruent to the hypotenuse ZY, and leg AB is congruent to leg XY, then triangle ABC BC is congruent to triangle XYZ. All right, for these next ones, we're going to decide whether we can use angle, side, angle, angle, side, or hypotenuse, leg to prove that the triangles are congruent. If so, we'll write the congruence and identify the postulate. If not, we're going to write not possible or NP. So, this first one, we have triangle ABD. Well, it looks like B has some congruence there, and D has some congruence there, and BD is shared by both triangles. As such, we can say that triangle ABD is congruent to triangle CBD by the angle, side, angle postulate. This next one, triangle CBD. So CBD, looks like we have an angle there marked for congruency. Looks like we have a side there and a side there marked for congruency. And we've got a vertical angle set up such that these two angles are congruent by the definition of vertical angles. Just circling that vertical angle area for us. Pay attention to. As such, we can say that triangle CDB is congruent to triangle ABE by the angle, side postulate. All right, looks like these still didn't want to work. Folks, these little squares here are supposed to be down here. I tried fixing it on the notes already, and it didn't want to go. So those little squares are supposed to be down there to indicate H and K are right angles. As such, because we are dealing with right angles, these are right triangles, which means we only have one option if we can actually have congruence. So let's check. GHF, so GHF is congruent to, well, we've got a right angle, so right triangle, we've got a hypotenuse, and we have a corresponding leg. So as such, we could say that they are congruent by, is congruent to LKJ by the hypotenuse leg rule. Two more. So now we want to look at triangle FGE, and we have an angle, we have a right angle, and we have a shared side. Okay, so we don't know anything about this hypotenuse, so we know right off the bat that if we have congruency, it's not going to be because of the hypotenuse leg rule, even though we have a shared leg and an angle between them. What we do have, though, are an angle, and a leg, or in this case, a side. So we could say that triangle FGE is congruent to triangle HEG by the angle, side rule. Note, folks, hypotenuse leg can only be used in right triangles, but that doesn't mean that the other ones cannot also be used in right triangles. All right, last one. Triangle BDA, so BDA. We've got some congruency on that B angle, some congruency on that D angle, and a shared side between them. As such, these two triangles will be congruent, specifically that BDC will be congruent to BDA by the angle, side, angle rule. And that, folks, are your answers to these practice problems. In today's folder, you will find another little practice ungraded assignment for angle, side, angle, side, and hypotenuse leg, as well as an activity escape room zombie escape room, virtual escape room for y'all to complete. If for whatever reason you don't like zombies, please, or you just don't like the assignment, please feel free to do the alternative assignment that will be posted around 6th period today. Take care, folks.